Welcome guys, and in this video I'm going to explain how to write Verilog code for half adder in behavioral model. I have already written the code here with the module name of half underscore 3. So the inputs and output combinations won't change like in data flow model or structural model, it doesn't matter. But here in behavioral model you will use the keyword always. Okay, after using the keyword always or writing the output variables in begin or and in between begin and end, then you should use the data type as reg. Irrespective of whether you are designing a combinational circuit or sequential circuit, it doesn't matter. But if you are writing in the behavioral model, you should declare output variables as reg. Then you might get the doubt that what is the requirement of writing reg if writing combinational circuits. So the synthesizer will understand depending on the code that you're writing whether it's combinational or sequential, and it will won't allocate any memory elements to the circuit. Purely designing a combinational circuit is also possible, but behavioral level of coding is highly preferred to write for sequential circuits, and for sure you have to declare your output as reg type. And here see, the statements are similar, that a XOR b is given to s and a and b is given to carry. So but you should use always, and this star indicates that any change in the input variables, in all the variables, if there is a change in variables, then this block will be executed. Okay, or you can write here a or b or like that, anything, but star is also one way of writing, so I use it star here. That means any change, if at all any changes occurred in the input variables, then this will be executed. Okay, so now if you want to synthesize the circuit, you have to write a test bench, which I have already written, and this is same for any model, data flow or behavioral or structural. You have already seen those two videos, I guess, that is in data flow model and structural model. Again, the test bench is similar to that. Here you can see dollar stop or dollar finish. You can use a dollar monitor statements and all the input combinations and all. Now if I run this code, or if I check the syntax and simulate the behavioral model, the graph would be same that you obtained. Okay, so let me okay, see, you can see for all input combinations 2 nanoseconds it's changing. So the values and all will remain same irrespective of the type of coding. And also you can check for this RTL schematic also. Here you can check RTL schematic. It also it will be also same if you check the RTL schematic like we have seen in data flow model. So let me view the RTL schematic of this half adder. Okay, now you can see here. Okay, so this is how it would be. So that is how you can design using behavioral model. This is a half adder. Hope you guys loved this, learned something new in this video. So that's all for this video. In the next video I'm going to explain how to design a full adder using all these three abstractions. Basically there is also one more abstraction, that is of switch level, but we usually won't use that for time being now, because we won't design at transistor level, like we don't use keywords like NMOS, PMOS now itself. So let us stick for these three types of abstractions, that is data flow, structural and behavioral. In the next video I'm going to explain how to write a Verilog code for half adder and in all these three levels of abstraction, and then we are going to see how to use the instantiation of how to use these half adders and building a full adder circuit using half adders, and all these things we are going to see in the upcoming videos. So stay tuned and please subscribe if you're not done yet, and click on bell icon for more updates and more videos. Thank you for watching. See you in the next one.